third section of the West African Examination, Senior Secondary School Mathematics Examination for Liberian schools. In this video, we're going to be discussing a section on statistics. We're going to focus here on the objectives of just reading and drawing inferences from graphs and interpretation of data in a histogram. So this video is going to be very short and very basic and to the point. Well, these are different graphical representation of data: line graph, bar graphs, bar charts, or circle graphs, frequency table, histogram, box and whisker plots, 10-minute plot. Some of these have not been featured on WAEC based on my own research. Now, the choice of which one of these graphs can be used to represent a data set has to do with whether the data is discrete, continuous, and what do you actually want to show. So the first of them is a line graph. We say it involves a horizontal line, a vertical line. You can have normally we have this line graph where we use the horizontal axis to represent the different categories and groups, and then the vertical axis represents the value of those different groups. Okay, normally it's used to show fluctuations like in rainfall, snowfall, and those kind of things like that. So we're in a, okay, good. So that's what it's used for. So then we have a bar graph. In a bar graph, we can have a horizontal bar graph or a vertical bar graph. We can have double bar graph, multiple bar graph. But in a bar graph, the bars don't touch. And we normally use bar graphs to represent non-numerical observations, correct? Good. We can make a bar graph with a number of students absent at a school day each day of the week. So the categories here, the day of the week, which is non-numerical category. A circle graph is something like a pie chart. So we call it a chart, pie chart, because it's like a pie. So you have pieces of a pie, like a pie which you eat. So each part represents different categories. One of the concepts you take into consideration when you're making a circle graph is the fact that a complete circle has 360 degrees. Then very similar to the bar graph is a histogram, but except that in a histogram the bars will touch. Okay? So to make a histogram, we normally would group our data. We put our data into classes. We identify the class width. No data should belong to more than one class. The class should not overlap. But we're going to talk about something we call class boundary and those things that would create opportunity for you to really make the bars of the histogram to touch, even though the data, the categories would not be overlapping. And they say you can use between 5 to 12 classes in a circle. Okay. So a histogram, one of the best ways to begin making a histogram is to start with a frequency table, and then you identify your class interval, which is a range of values that belong to a class. So if the values in the class is from 70 to 74, your class interval is from 70 to 74. But then your class boundary, when you are making the histogram, your class boundaries is something you do so that the bars will touch. So you can go to the left of your class interval and you go slightly to the right of it, equal intervals. The class width, we say it may not be equal, but most of the time we try to make it equal so that the part of the histogram can represent the actual thing. And sometimes you can make a bigger histogram with using the mid-value of the class interval. And we say the motor class, the mode, is the class with the highest frequency. So here's problem number one we have here. So what is the class boundary of the motor class? Now, that's a very important concept I wanted to lay down here. Well, what we see, and this is B, problem B, how many students are considered in the sample. So what we see here, over here, what we have been given is just the class, this is mass. We've been given the class interval. So to find the class boundary, it's a multiple choice question. To find the class boundary, so that when you make the histogram, the graph will overlap, you can just go to the left and right of the class boundary. Now, let's find the motor class. The motor class is the class with the highest frequency here. The class with the highest frequency here will be 70 to what? 74. If you look on the WAEC for this problem, taken from WAEC Liberia 2009, problem 6 and 7, you will not see this because what they are interested in the class boundary. To find the class boundary, for example, you subtract 0.05 from this and you add 0.05 to this. So when you do this, you're going to have what? 69.5 you're going to have the class of 69.5 to 74.5. So that would be your motor class. Again, understand, here you have the class interval. To form the motor class, you do this. Because when you do this and you make the histogram, the bars in the histogram will touch. So that's something you do to make the class. So note the difference between the class boundary and the class interval. So here you have the class interval, and here you have the class boundary. So the class boundary will allow for the bars of the histogram to touch, but it will preclude the possibility of any data belonging to two different class classes. Now, so let's move to problem number 2. Look, we didn't finish it. Then it said, how many students are considered in the sample? To find the number of students in the sample, you just add the frequency. Because, for example, the students in the math category of 60 to 64 are 4. So let's add the number. 4 and 7, that will be 11. 8 and 6 will be 14. And then we have 5. So 5, and that's going to be 16 and 14. So that's going to be basically 30 students. Okay? So 30 students were in this situation here. So here, this is part 2. It's 2x degree. This is x degree. And this is part 4. And here we have, this is part 3. And this is part 1. Part 1 is 120 degrees. This is going to be x degrees. So part 2 is 2x degree, part 4 is x degree, part 3 is x degree, and part 1 is 120 degrees. Now they want us to use this information to calculate the value of x. So what we know is that when we add all of these degrees here, they must sum up to what? 360, because the sum of the interior angles of any circle is 360 degrees. X plus x is 2x plus 2x is 4x. So we have 4x plus 120 equals to 360 minus 120 minus 120. We have 4x is equal to 240 divided by 4 divided by 4. X will be equal to what? 60 degrees. So the value of x in this thing is 60 degrees. Now, how many undergraduates are in part 3? Where is part 3? Part 3 is just basically x. So what we need to do, we need to know what part of 60, what part of 360 is 60. So we do 60 over 360. And they wanted us to know the percentage. Yeah, right? How many undergraduates are in that part? And it was 900 undergraduates here, so we can easily do that. So we times that by what? 900. This gave us a fraction of, and so we can do that. So let's go and cancel this, cancel this. So 6, go here 1, 6 goes here what? 6. So we're going to have 900 divided by what? 6, and when we do that, we're going to have 100 what? 50. So we have 150 undergraduates in that category in part 3. So again, thank you. We had just 2 basic problems in this section here. This has been a production of FIELD, the Foundation for Equity and Excellence in Education in Liberia. We are committed to providing quality content instructional materials across all content areas. Please support our cause. You may visit us at www.fieldliberia.org. And whilst you are there, don't forget to make a contribution. Also, like us on Facebook, follow us on Twitter, and don't forget to subscribe to our YouTube channel. Thank you very much.